This video is about double angle formulas, sine of 2u, cosine of 2u and tangent of 2u. Double angle formula, sine 2u equals to 2 sine u cosine u, and cosine 2u has three different forms. Cosine 2u equal to cosine square u minus sine square u, or 2 cosine square u minus 1, or 1 minus 2 sine square u. Tangent 2u is equal to 2 tangent u, or 1 minus tangent square u. Use double angle formula sine 2u equal to 2 sine u cosine u. Use the double angle formula to rewrite the expression 8 cosine x sine x. So let's start with 8 cosine x sine x. Rewrite 8 as 4.4 times 2. So you have 4 times 2 sine x cosine x. Now use this 2 sine u cosine equal to sine 2u with u is equal to x. So you can rewrite this as sine 2x. We have 4 times sine 2x. So that's the answer, 4 times sine 2x. So example 2, using double angle formula, sine 2u is equal to 2 sine u cosine u. So use a double angle formula, this one, to rewrite the expression sine x cosine x. So let's start with sine x times cosine x. So in order to apply this formula, you have to do multiply and divide by 2. So let's say divide first one and multiply with the 2. So now 2 sine x cosine x is similar to this one, 2 sine u cosine u, which is sine 2u. Now if you put change x to u to x here, and it becomes something like this. So now this is equal to sine 2x. Bring down 1/2. So the answer is 1/2 sine 2x. So example 3, now we're going to use double angle formula cosine 2u. Use double angle formula to rewrite the expression 8 cosine square x minus 4. So let's start with 8 cosine square x minus 4. Let's factor out 4. So you will have 4 times 2 cosine square x minus 1. And now we have a formula 2 cosine square u minus 1 is equal to cosine 2u with u is equal to x. So this looks similar to this one. So if I change x u to x, so this almost becomes this one. So you do the same thing, change u with x. So this is equal to cosine 2x. So bring down the 4. So the answer is 4 times cosine 2x. So example 4, use double angle formula cosine 2u. Use double angle formula to rewrite the expression 4 minus 8 sine square x. So let's say 4 minus 8 sine square x. Looks like we can factor 4. So you will have 4 times 1 minus 2 sine square x. And we have a formula 1 minus 2 sine square u is equal to cosine 2u with u is x. So if I change this u with x, and also this one, so this becomes like this one, which is cosine 2x. So we're going to change this to cosine 2x and just bring the 4 down. So the answer is 4 cosine 2x. So example 5, using double angle formula. So we're going to use the figure to find the exact value of the trigonometric function. So this is the triangle given to us, and it has sides 3 and 4, but it doesn't have hypotenuse. So the first step is we're going to find the hypotenuse. So let's see, B is 4, which is adjacent to the angle theta, and A is the opposite to the angle theta, 3. And we're going to find the hypotenuse, and hypotenuse is equal to C. And from the Pythagorean theorem, C is equal to square root of A square plus B square. So now we substitute here, A is equal to 4, B is 3, so this becomes square root of 3 square plus 4 square. Now 3 square is 9, 4 square is 16, so now we have a square root of 9 plus 16, which is square root of 25, and square root of 25 is what? 5. Now we have a completed triangle. So its adjacent is 4, opposite is 3, and hypotenuse is 5. So now we're going to use this completed triangle and find sine theta. And sine theta, the formula is opposite of hypotenuse, and opposite is 3 and hypotenuse is 5, so it becomes 3/5. So then we find the cosine theta, and cosine theta is the adjacent over hypotenuse, and adjacent is 4 and hypotenuse 5, so cosine theta becomes 4/5. Now we have to find this one, sine 2 theta. The first thing we do, use the formula for sine 2 theta, which is 2 sine theta cosine theta. Using this formula, sine 2 equals to 2 sine u cosine with u is equal to theta. Now we just substitute sine theta is 3/5, cosine theta is 4/5. So now we have 2 times 3/5 times 4/5. Now we simplify. So it looks like we can multiply 5 times 5, 25. 2 times 3, 6 times 4, 24. So sine 2 theta is equal to 24 over 25. So example 6, using double angle formula. So we're going to use this figure, this one, to find the exact value of the following trigonometric function, cosine 2 theta. So again, looks like the triangle has adjacent is 4 and hypotenuse 5, but the opposite is missing. So first thing we're going to do is complete the triangle, and then we'll find the missing side, which is A. So let's say given to us B is equal to adjacent 4 and C is hypotenuse 5, and we're going to find the opposite, and opposite is equal to A, which is from the Pythagorean theorem is square root of C square minus B square. Now we substitute C is equal to 5, so it becomes 5 square, and if put 4 here, it becomes 4 square. Now we simplify. Square root of 5 square is 25 and 4 square is 16, so it becomes square root of 25 minus 16 is 9, which is 3. Now from this completed triangle now, and we apply find the sine theta, which is opposite over hypotenuse, and opposite is what, 3, and hypotenuse 5. Similarly, cosine theta is adjacent over the hypotenuse, which is what, 4/5. Now we rewrite cosine 2 theta using this double angle formula, cosine 2 equal to cosine square u minus sine square u, with u is equal to theta. So in other words, if I put u with the u is put theta, so this becomes like this one, cosine 2 theta. So we do the same thing on the right side where u is theta. So you will have cosine square theta minus sine square theta, and that is equal to cosine 2 theta. So now we substitute in this formula, sine theta is 3/5 and cosine theta is 4/5. So this becomes 4/5 square minus 3/5 square. Now this square, this one becomes 16 over 25 and minus 9 over 25. Now we can subtract because they have same denominator. So 16 minus 9 is 7. So the answer is 7 over 25. So example 7, using double angle formula. Use the figure, this figure, to find the exact value of the following trigonometric function, tangent to theta. So given triangle has opposite side is 3, hypotenuse is 5, so adjacent is missing. So we're going to find the adjacent first. So well, A is 3, which is opposite, and C is equal to hypotenuse, which is 5. So we're going to find adjacent, which is B, and Pythagorean theorem says that B equals to square root of C square minus A square. Now C is 5, so it becomes 5 square minus, and A becomes 3 square. So we have a square root of 5 square minus 3 square, so which will be square root of 25 minus 9, and 25 minus 9 is 16, so it becomes square root of 16, which is what, 4. So we put 4 here, and now we have a completed triangle. Opposite is 3, adjacent is 4, and hypotenuse 5. Now from this triangle, we need to find tangent theta, and tangent theta is opposite over adjacent. So opposite is 3 and adjacent is 4, so tangent theta is 3, 4. Now to find tangent to theta, we have to rewrite tangent to theta in terms of tangent theta, and we have a formula, double angle formula, tangent to u equals to 2 tangent u or 1 minus tangent square u. So if you put theta where the u is, so this becomes tangent to theta, and this becomes 2 tangent theta over 1 minus tangent square theta. So in other words, tangent 2 theta using this formula is equal to 2 times tangent minus 1 minus tangent square theta. Now we just substitute what is tangent theta we just found, 3/4. So this becomes 2 times 3/4 over 1 minus 3/4 square. Now this we can multiply 2 times 3 is 6/4, and this we can square it, become 1 minus 9/16. So now we combine these two because so yeah, in order to complete this one have to change something with this denominator 16. So it looks like it should be 16 over 16. So now we can subtract the 9 from 16. So now we have 6 over 4 and 7 over 16. And now 6 over 4 multiplied the reciprocal of 7/16, which is 16 over 7. It looks like we can divide 16 by 4. So it gives you left 1 here, and so it becomes 6 times 1, 6 times 4, 24 over 7. So tangent 2 theta is 24 over 7. Example 8, we're going to find sine 2u, cosine 2u, tangent 2u. And we're going to use the given condition to find the exact value of sine 2u, cosine 2u, and tangent 2u using this double angle, using the double angle formula. So given is sine u is equal to minus 3 over 5, and the u is between 3 pi over 2 and 2 pi. So now if you say 3, it looks like 3 pi over 2 is less than u, less than 2 pi, means u is in quadrant 4. And in quadrant 4, cosine is positive, and therefore to find cosine u, we're going to use the following identity. Cosine equal to square root of 1 minus sine square u. So it's a plus sign here. Now we substitute sine equal to 3/5. So this becomes equals to square root of 1 minus the square of minus 3/5. So now we can simplify this to be 9 over 25. So you have a square root of 1 minus 9 over 25. And then we combine this as a fraction. We can change 1 to 25 over 25, and this is 9 over 25. Now we can subtract 9 from 25, it becomes 16 over 25. So this is equal to 16 over 25. Now we take the square root of each. So square root of 16 is 4, and square root of 25 is what? 5. So now we have sine u equal to minus 3/5 and cosine u equal to 4/5. So to find sine 2u, we can rewrite sine 2 is 2 sine u cosine u. That's the formula. And we substitute sine equal to minus 3/5 and cosine equal to 4/5. So this becomes 2 times minus 3/5 times 4/5. So it looks like we can multiply 2 times negative 3 times 4 will be then negative 24, and 5 times 5 is 25. So that's equal to negative 4 over 25. Now to find cosine 2u, we write cosine 2u as cosine square u minus sine square u. Now substitute sine equal to minus 3/5, cosine u is 4/5. So we become 4/5 square, and this becomes 3 minus 3/5 square. So it becomes 16 over 25, and then minus square of 3 square over 5. So it will be 9 over 25. Now we can subtract 6 by 9, 7. So I'll say 7/25. And now to find tangent 2u, we can write sine 2u over cosine 2u. Sine 2u, which is found minus 24 over 5th, and cosine 2u is equal to 7 over 25. So this becomes minus 24 over 5th times the reciprocal of sine over 25 will be 25 over 7. So 24 becomes, this become 25 cancel out, you have negative 24 over 7.